Those who are sitting at the back, please fill up the first rows. Esteemed dignitaries, respected principals, sir, deans, HODs, faculty members, and my dear fellow students, I, Shantika Nayak from 3rd year CCTS, and it is my absolute pleasure to welcome you all to this exclusive speaker session hosted by the Department of Computer Science and Engineering in collaboration with GDG on campus MCKVIE. To begin this afternoon on an auspicious note, and seek the blessings of the Almighty, I would like to invite our dignitaries to come forward for the Ganesh Vandana, the traditional light lighting ceremony. Now, I would like to invite our respected principal of MCKVIE, Professor Dr. Obijit Naidi sir, to deliver the inaugural address.
So, good afternoon. The young innovative minds of MCKVIE, the most enthusiastic guys who are present here, and this is yet another program that is coming up from the Google Developer Group of MCKVIE. On behalf of the developer group and also at large on behalf of MCKVIE, I welcome Mr. Nilabza Som to spare his valuable time for all of you. So it's a very, very special occasion that he will be hearing something from Mr. Som, who is presently associated with Google. So I hope that he will be benefited by the insights that will be coming from Mr. Nilabza. So be attentive, be mindful, and enjoy the session. I will, on behalf of MCKVIE, I welcome all of you, and especially thanks to Mr. Som to be here with us and have a very nice afternoon and a very, what I would say, informative afternoon, which may help you to think of design of your projects in future. So thank you all who are here. Thank you. I would ask Mr. Som to excuse me because I have a meeting. Thank you very much, sir. Yes. Okay.
Thank you, sir, for those inspiring words. We shall proceed with the felicitation of our esteemed guest, Mr. Nilabza Som, with a token. Mr. Nilabza Som, with a token of appreciation. It is now my distinct honor to introduce a visionary leader from the heart of the global tech industry. Today we are joined by Mr. Nilabza Som, sir, who currently holds a TPM leadership position at Google. Nilabza Som, sir, is a senior technological professional and engineering leader with extensive experience in building and scaling large-scale software systems. He currently works as an engineering lead at Google, where he contributes to high-impact engineering initiatives, system modernization, and technical mentorship. Prior to this role, he was associated with Amazon, gaining deep expertise in distributed system, cloud infrastructure, and performance-critical applications. Sir is actively involved in the technological community through reference talks, knowledge sharing, and mentoring aspiration engineers. His professional interest includes system architecture, cloud migration, artificial intelligence, and engineering. Complex technical problems at one of the world's most innovative companies, Sir brings a wealth of knowledge in building large-scale systems. Today, he will be enlightening us on the topic understanding and designing massively parallel system or application. This is a rare opportunity to learn how global tech giants handle massive computations and data problems. Without further ado, I would like to invite Mr. Nilabza Som to take the stage.
Thank you. Hello, good afternoon. Just let me know if it's okay for me to walk around here or I can walk there. It's fine. I mean, I just don't want to be overwhelming for all of you to just keep going inside. If this is okay, I can walk. I just need to have a look at the slide. So if that's okay, is that okay with all of it? Okay, cool. First of all, sincere apologies. I know a lot of you have just finished your semester paper and you have been asked to attend this. So probably I wouldn't have ever done that. But that's okay. I'll try to make it as engaging and interesting as I could possibly. And then we'll go from there. I think I got a very big introduction. I appreciate the help from the MCKVIE community, so really appreciate that. I won't dive into any other details about who am I. I think you've heard a lot about who am I. Let's get deep into this topic. I think how I want to talk about this or how we want to frame this session is we can spend 30, 35, maybe 40 minutes at max where I talk about system design, how we want to think about system design, and then I want to understand from you what are your expectations. We can do a Q&A type of thing. If you have questions, more than happy to answer any of that, and we'll go from there. Does that sound okay like an agenda? Okay, cool. All right. Okay. I just wanted to create an infographic. Sorry, I'm overtly indexing on Notebook LM that's newly launched by Google, but I'm not here to sell Google products. I love cartoons and infographics. That's why I just created this as to why do you even want to hear this? Why do you even need to understand system design? I think this is just my perspective of why every single developer needs to understand system design. You should, like every developer should inculcate. It's not, probably not part of a formal curriculum, but it's more about your exposure to say, okay, I made an app, I'm building something on the side, I'm vibe coding these days, and then suddenly it becomes insanely popular. Just for a fun fact, Notebook LM was built by 4 engineers at Google. They never knew that it will become a global phenomenon, even like 6 months ago. So, what helps you succeed at that scale is when you design your systems and applications to sustain and perform at that scale, which is why I fundamentally feel that you need to have an understanding of massively parallel systems, how do they operate, how do they perform at scale. You don't want to build a system that only has a spinning wheel when it is logged in from Africa where the network bandwidth is very, very low. You are not building a global system assuming that you do not have a system constraint. You are building a global system assuming that you have a maximum amount of constraints that you possibly can operate within. Right? That's the fundamental theme or value prop for doing system design. Of course, there are career manifestations of you can have career paths in terms of you go to a senior engineer, or you want to do jobs at these tech companies. You will be evaluated to understand what's your system design thinking at scale. It's not about 100 users. It's not about 1,000 users. It's about a few 100 million users. How do you even build a single login page that logs in 500 million users at the same point in time? Just login, right? Gmail does not have a lot of business use cases, but Gmail is used by 1.5 billion people. And imagine the number of people who are logging into Gmail at the same point in time that has a very broad spectrum of network constraints, organization policy constraints, country policy constraints, and all of that is encapsulated and abstracted from you. You are just logging into Gmail and it should work. Whether you are in Nigeria, whether you are in New York, whether you are in MCKVIE, it doesn't matter. So you need to operate at scale for a massively parallel system, even if it's a use case is bare minimum, right? So that's the fundamental proposition of understanding why I need the system design. The other part is, of course, there are manifestations of doing, these apps or ride share or cloud gaming and computing. Those sound very lucrative. To say, oh, I'm an app developer, I'm a game developer, but you imagine that your game is now being played by 100 million people. How are you going to handle that? So that is very, very important that you understand the behavior of system at scale. That's another reason why I feel you need to understand system design, right? And this, let me tell you, there is no formal curriculum to do it. You have to iterate on it, you have to build on it. As you build your app, as you learn through, as you debug, sometimes as you understand from how other apps are doing, right? How is Zomato handling the traffic or how is Amazon handling the traffic? We are learning on the way as well. So that's also there. So there are different avenues or channels to learn it. Trial and error is probably not the preferred way to learn. I would rather prepare when you are in college, when you have that spectrum to spend time on learning, you would maximize that opportunity to understand how are these systems designed. So that's the premise of this. What we do. So it's the way it starts, the way any place you do a system analysis and design, and you do it as well. But one of the fundamental ways to do it is who are you building this system for? Who is it for? Who's the customer? Who is this product for? Right? If you are building an app for people to be able to ride share, those commuters are your customers, right? You are not building that app for somebody who checks in for their flight at the airport. That's not the goal. So you need to be very, very clear on the product vision of who is this for. How would it help? Like, what is that use case or problem statement that you are trying to solve by building this software, by building this product? Right? Understanding the product vision and working backwards from one of the ways to do that is, like how Amazon does it. It's called a PR FAQ. It's like press release FAQ. It's a very popular technique. You can look it up in the internet. It's like you have a product, and what are you celebrating on the launch day of the product? Like, what are you telling the people, the press, and every other customer on the launch day? And you work backwards from that. So say, okay, I'm celebrating my rideshare app so that everybody knows the exact time it takes to go from Nilabza station to MCKVIE, and it's completely predictable. I have that behavior, and doesn't matter if it's 100 people or like 500,000 people, it will exactly perform at the same level of efficiency. That is what I'm celebrating at the launch of my rideshare, for example. So that is why you create this. It is good to write it down, even if you're doing a student project today, right? Write it down. What problem is it going to solve? Who is your target customer and what is your problem statement, right? And you work backwards from that. That will help you to course correct as you go through the design, as you go through the requirements. Like even for every phase of SDLC, that's your pullback or checkpoint. Right? So understanding product vision, understanding who is it and how would it help is a critical dimension. What we do today, we take a very simple. We will say user needs to upload videos on share, and users can search and comment on the videos. Very, very basic requirement. This is your system that we are trying to build. Right? So we know that these are the two goals of the system that we are designing. Right? Okay. So make sure you have this at the back of your mind, so that you know every time you're in doubt, you go back to the statement and say, okay, wait a minute. I don't want to over-engineer this. I do not want to under-engineer this. Okay. Okay. Another critical element is what this is not supposed to do, right? What's the out of scope? Very, very important. When you are in college or when you are in a startup or when you are even, regardless of where you are, it is very important to have a system boundary. What will this not do? have to be very clear, because tomorrow you might feel a competitive. Okay. The other aspect is you need to know your non-functionals very clearly. Like I was mentioning, right? Like you have a simple login page, or you have this video sharing app. What we are saying is any video uploaded should not be lost. Very basic requirement. You cannot do without this, right? So this is it's your non-functional. You will call it NFR, right? So you have to finalize what are my basic non-functional requirements for the system, right? So you have the video should not be lost. The system should be highly available. It cannot be that, just because I have logged in from the platform station at Lilua, it's not working. That cannot work. That should never be the case. So it's highly available. Consistency can take a hit. That's all for now. You're building a system, you're starting it. Consistency can take a hit in the interest of availability. I need to have the system as highly available. There are ways to measure that. Of course, they say 99.49 is the highest classical way of measuring the system availability. But let's say we say it's highly available. We can create those subjective benchmarks as to what is the definition of highly available, even define it from your app scope perspective. And then users while watching videos should not have any lag. So there should not be any real-time lag in your system for this use case. There should not be any lag. These are our fundamental non-functional requirements that we are starting to build. Okay? So everybody is with me on this up to this point? Okay, you can stop me anytime by raising your hand. Right? I'm fine to just get any of your questions clearly. Okay. All right. The next is now you're slowly getting into how are you going to estimate the capacity? Somebody who's just starting a business or somebody doing a startup or even this GDE forum, you are in a competition. You need to understand how much resources do you need. How will you estimate the capacity of the system based on the constraints that you had assumed, right? Or the non-functional requirements that you had established? How do you even build down the capacity? What we are saying here is 1.5 billion users on the planet, like 1.5 billion people, and then there are 800 million of whom were active. So we are assuming that this is a global app. 800 million people are going to use this, right? A user views 5 videos per day. Now, remember, a very critical element of system design is assumptions. Like I said, you have the requirements. Based on the requirements, you have to have some broad stroke assumptions. Even if you're asked in an interview as to how do you do a system design like that, you have to ask clarifying questions. You call on what are your assumptions. Our fundamental assumption is the user will use 5 videos per day to determine the initial capacity. Okay. So total videos per second would be 46K, right? It's a basic math. You just divide by the number of seconds in a day. So you have 46,000 videos per second. The next assumption that we are going through now is how, like I'm a user, how many videos do I upload versus how many videos do I view, right? So let's assume there's a ratio of 1 to 200. So I'm constantly scrolling on my mobile. I watch 200 videos, but I upload one. in that ratio. That's another assumption that is very, very important. Right? This gives us that you have 230 videos uploaded per second, 46K by 200. Yeah. So you have, that's your upload bandwidth, or that's your upload resource demand. Okay. Now let's talk about the storage. Where do you store this? Right? We say assume every minute 500 hours worth of videos are uploaded. That's another assumption. Now you could ask me a question at this point. How many of these assumptions, like what are the assumptions based on, right? You need to have a basic understanding of looking at other apps, other competing products or parallel products that are already there. You need to do a product usage survey or a product analysis survey to say, let me look at Zomato if I'm building a Zomato parallel, or let me look at Swiggy if I'm building a Swiggy parallel to say, what's their upload ratio? What's their view ratio, right? And then you derive out of that this is your assumption. Okay? And then you might not have a lot of money to spend as Swiggy or Zomato might have at this point in time. You're just starting up a new app, you're building it. So you define storage estimates, saying, okay, 500 hours worth of videos are uploaded. 1 minute of video needs 50 MB. That's again just a standard average of what you can expect of a video based on whatever you have seen in the demographic. It could be global average, it could be local average, but you're assuming that 1 minute of video needs 50 MB. If somebody is uploading a whole 5 or 3 hour movie, it's going to overshoot, but this is just a standard average, right? So when you do that, you're saying, okay, which tells me I need 25 gigabytes of storage. I need 25 gigabits per second of storage to run my app. Very, very important to understand what is my resource constraint here or what is my resource need. Okay? So you establish the storage estimate and similarly you do the bandwidth estimate. Right? So I've taken an assumption here that we're uploading each minute of video takes 10 MB of bandwidth. Now remember, the first thing that I mentioned here is one of your friends is uploading videos from Nigeria. One of the friends is uploading videos from Mozambique. You might have a very, very broad spectrum of bandwidth that you have to deal with for your, right? So you need to define what is your standard bandwidth requirement on an average. Will it be 100% right? Absolutely not. That's not how you build systems. But should it be closer to the average based on the data that you have collected? Absolutely yes. That's how it should be. Okay. Now, you do that, you do the bandwidth estimates, assuming each upload of the video takes 10 MB. We would be getting 300 GB of uploads every minute. That's your bandwidth need right there. Even to operate at that assumption average, we need 300 GB of uploads every minute. How much will we need for the ongoing outgoing bandwidth? Because we are uploading, we need 1 terabyte. So now you are at a point to say, okay, X number of storage, Y number of bandwidth. Like ignore the numbers here. What I'm trying to get at is you have to define your resource capacity in terms of storage, in terms of bandwidth. And this will also help you to understand what's the system bottleneck. Where is it going to break? Very, very important for ongoing monitoring and scaling up your workload. Right? So you need to understand what's my performing average? Is my assumption close enough? You have to do that when your system is live. You have to keep monitoring that and you have to reassess on an ongoing basis what's your capacity estimation. Do I need more storage? Can I free up? In the days of cloud migration now, in the days of cloud computing, you can do elasticity. Right? You scale up or scale down based on your average. If you are scaling up or scaling down too fast, which means your assumptions were incorrect in the beginning, right? But it's okay. It's a course correction. It's an iterative process. You start somewhere and you go ahead. So now you have determined what are your capacity estimation and system constraints based on the basic requirement that we have. Okay. So now I think computer science we love APIs, we love to create soap, REST, Now whether you need a soap or you need a detergent, It's up to you. It's up to your design. It's up to your break-even points. Right? Where does it fit? Do I need SOAP for my search and stream? Do I need REST? You take a call. That's a design call. When you are designing these systems, based on the load that you have adjusted, you decide what kind of API you're going to do. Where is it going to fit in? And we'll come a little bit later on exposing the security risk, exposing the data. For a right share app, you're probably okay. But think of it if you are adding online payment or UPI payment gateways to subscribe to that ride sharing app. Now we are talking about personal data that now needs to get exposed via the API call. How do you decide which API to use now? So as you build through the system, what I'm trying to get at is you might go back and forth between SOAP and REST. Not always, not ideal, but there could be situations. New compliance laws come in, right? New regulations come in. You might require to think of redesigning or rechanging. Very expensive change. Not recommended, but it can happen. So be open with the fact that yes, I can change my SOAP or REST based on the requirements. Okay? So I want to give a pause. Fast or is it too slow? Is it okay? All right. Now, now we talk about we have the basic infrastructure, we have the basic API. Now we're talking about the components, right? What's my processing queue going to do, right? I'm going to encode the thumbnail generation and storage. Fair enough, because there are system requirements, there are compliance and policy requirements. So I might have to do encoding, I have to do thumbnail generation and storage. Those are my places for doing the processing. How am I going to encode? To encode each upload video into multiple formats. Fine. Somebody might need a base 64. Somebody might need for encryption, they might need an AES. There are different encoding needs for encryption or otherwise. I need to decide how many videos or how are we going to be encoders. Thumbnail generators. That's a critical component because we are going to generate few thumbnails for each video. It's a global app. You need to have thumbnails. Not everybody, like thumbnails was the backbone of how YouTube Shorts was born. People have less patience. They honk so many times on the road. That's why they need thumbnails, right? So they start. So that's how you start building thumbnails, and you need a thumbnail generator. Fair enough. You need a storage for those thumbnails. Fair. You need a database to store information like name, email address, assuming that it's persisting beyond the session. So your rideshare app, like I said, is now a subscription model and you need to persist beyond the session. So you need to store the credentials and it's in the user database. And then you have a very important component of metadata storage. Very, very critical in today's world where you have like a multi-dimensional data sources to store content data. Now think of content being multimodal today in today's world. It can be video, it can be like text to speech, it could be anything of that stuff. So you need a very robust, secure metadata storage for all of these metadata databases. Okay. Yeah. So now that we know the components, we have identified the constraints, we have had high level understanding of the resource needs. Let's dive a little deeper to say, okay, what do I need for the file storage for the videos? You know, I have just put in my perception here. You can use any file storage. I did not want to recommend any cloud storage or object storage. It's completely dependent on what use case you're running. For my simple use case that I've taken, I do not need an S3 bucket or an object storage. I've just said HDFS is fine for me, right? Because I just need files to be stored for now. There's no object storage required. Now, how should we efficiently manage the read traffic? Should we segregate our read traffic from write? Right? So there's something in computer science called consistency. You have a read, write, and eventual consistency. Two types, right? What's your use case? What's your boundary or band like perimeter? If there is a need to segregate, today 99% of the time the best practice is to segregate read and write traffic. So you should be segregating read and write traffic so that you like if you have a constant polling use case, or if you have like even an asynchronous use case, it is a best practice these days because of the volume of the usage that you would segregate read traffic from write traffic. Can we leverage local caching for hot links and thumbnails? Completely dependent on the use case. For our use case, yes, because our thumbnails will be very, very limited. It's a share app or it's a video upload app. It will be running in KBs. It will not hurt my source assumptions. I don't have to buy storage on the fly. So it's okay. I think I can manage with local caching for hot links and thumbnails. Now, if there are security requirements, I'm not going into it right now. We can talk about it in some time. But if there are security requirements, we have to rethink about it, how you want to keep your cache content. Can you really cache your input? So that's that. Now, metadata sharding, right? I don't know. So one thing, let me take a pause here. Some of these concepts, I'm assuming most of you are in the second and third year of the BTech, right? Some of these concepts could be alien to you at this point, which is fine. You're hearing keywords, fine. But I find if it's okay, if I'm using these words and you're like, this is tangential, that's fine. Understand the reason for why we are doing this. That will help you to absorb this faster. And you can, of course, I don't know what's sharding. That's fine. You don't know what's sharding, just think about it that you need a way to efficiently handle the meta in your database storage, which cannot be just a simple relational storage. Right? So do we need metadata sharding? Yes, because your read and write traffic is high in this use case. You're talking about 800 million users who are active. So you do that. How do we factor dedups, right? Like you use block matching and phase correlation. Again, for the purpose of this audience, there are techniques to dedupe the content. These are algorithms that you can use. If you want to dedupe and remove the redundancy, there are algorithms available that you can leverage. That's not hard and fast. Also, again, completely dependent on the use. So I have a question. Sure. This is still the metadata sharding that comes. Yeah. So normally, if you have metadata that you want to just store, because if you're talking about video content here, I would have a hash key. I would shard using hash maps. So if I have the hash and I have the index of the hash, I will be able to shard it effectively. And one of the reasons I want to do this through a hash map is I want to intentionally maintain regional redundancies because my app is global. I have regional requirements. You have to layer the regional requirements with on top of your metadata file before that can be retrieved. So like in Europe, you like whatever happens in Europe stays in Europe as per the Digital Markets Act. Now, even if you have the video uploaded by the user in Europe through his YouTube channel, that person trying to access his video in North America when he's traveling on business has to be consented. So that is a rule that we will have to apply locally on top of that metadata layer for that same content. Whereas the same flies back and is trying to access that data file, there's no restriction because it wasn't created because your timestamp and your created by and your geo content. These metadata shows that you are in EU and you are accessing it from EU. Whereas the same guy goes back, you have to reapply those rules. So you have to shard it. There are many ways to shard based on the policy requirements, based on the business requirements. You can use that, but the most efficient way would be to hash that if you use that. Did I answer your question? All right. How do we factor dedupe? I talked about it. How do we load balance and minimize global limits? Like I said, somebody who's in Nigeria wants to use your app. Of course, they don't want to see what's the time. I might have taken a wrong example because our app is to check the traffic from Lilua station to MCKVIE. So probably you will not need it for but your app became so popular that now you are spreading it across the world. So any station to any station. Now you are using the same stack to populate in a country where the network bandwidth is still in kbps. How do you operate that efficiently without having them as a lag? So you need to load balance, you need to have a CDN that will help you to regionalize or sorry, internationalize the content. So it's important that we do CDN, we do there are other hashing also, but let's say CDN is good enough for now for the purpose of our use case. Okay. CDN is content delivery network. I'm throwing a lot of jargons at you. You can start googling them and knowing what are these. Do not be overwhelmed. That's not the intent. Just you just absorb the intent of this discussion. All right. Okay. So now we are at a point where we have identified the network requirements, we have identified resource needs, we have identified use cases, we know the components, and we know capacity estimates. That tells me we do have a design that works. Do I know that it scales? I'm kind of on the edge because we have made a lot of assumptions at the beginning, like X number of users, Y number of videos, Z number of ratio of upload to view. So we do have a design, we do have a system design. This is the system design that is in place that will work. Will it work for 800 million people at the same time? Will every other requirement that can come in? We'll have to figure that out. So your system design is 60-70% done at this point in time. However, what we can do now is let's add, let's say we start complicating it because your app is becoming popular. If you remember, what was our basic scope? We do not want to add recommendations to our list. There is no recommendation engine. But now we are saying it's becoming popular. Oh my God, let's do like a lot of people are using it. A lot of people are interested but do not know how to navigate the app. Fair enough. We will give them a recommendation. If you look at Amazon shopping, if you look at Facebook friends, or if you look at any other, I'm naming a lot of comments regardless. You have the recommendations. So your recommendations, you can start layering them as a user. Right? How are you going to do this? You're going to do, let's say, one of the techniques of doing that recommendation is to do candidate generation and ranking. Again, I will not be able to go into the depth of how it is done for the purpose of this discussion. But understand that there is a way of filtering. So this is the simplest way to think about this is it's me and my preferences that drive my next set of views as per what the engine is assuming. So there is a neural network that is understanding. Nilabza wants to understand the time because we have a session in MCKVIE tomorrow. He's trying to understand what is the exact time to commute there. So let me give him some recommendations. He can take a taxi, he can take a Toto and all that. So it's based on my usage pattern that I'm filtering from the neural network to give you the content back. Okay? And then you have ranking, of course. What is the best way? You have recommended me 5 different options, and now I'm confused. I don't know which one to take. Should I take a Toto? Should I take a local train? I don't know. You have to rank on those based on ranking and scoring models that happens at the back end. So when you buy a handbag, when a lady buys a handbag and then it goes back, they see a lot of handbags from everywhere. It's a consumption pattern filtering and ranking that's happening behind the scene for the ranking end. So that is the basis of doing recommendations. Right? So when you are doing a video recommendation, the thing that you do, am I running short on time? Oh, okay. Um, sorry. So yeah, I'll run through this. So ranking, to a ranking, you can do like collaborative filtering the techniques with the recommendation on top of the that you have created. Then you can do content moderation. These days, uh, it's prudent to do content moderation. You have to be humane with the apps that you build. You have to be able to be safe and secure. You cannot allow anybody to use your platform for malintent. So, and then you cannot moderate that with a human speed when 800 million people are using this. So when you are doing content moderation, one of the ways to do is, there's an LLP pipeline, again a heavy term, computer vision and NLP pipeline that does the visual analysis and audio analysis to say, okay, somebody is using this app for the legal, safe intent and not for any malicious intent. So that's one of the ways where you have now trying to build in some there are processing queues, there are frames that you can use to populate or to build a moderation, automated content moderation. Okay. Finally, semantic search. The current design uses a simple API, like what we initially built, where we said we can use a soap or a Rex. It's a simple API on search videos. This likely relies on keyword matching, just the metadata. What we need to do is slowly get into as the app goes popular, as your data dimensions of searching increases, that's when you can do vector embeddings and semantic search. Right? It is to just add more context to what you're searching. It is not about I have 8,000 viewers and 800 million viewers, and that's why you want vector embeddings. That should never be the goal. Your goal is what is the broad spectrum of my search with respect to the context, and then you apply the vector embeddings in semantic search. Okay, let's see. Finally, you have to make it safe. This is one of the key criteria in the modern day system design that you have to have security considerations. The reason to have security considerations is manifold, right? There could be government regulations, there could be, safety security considerations for from a business context and so on and so forth. You might have a leverage of a particular app or stack just because it's more secure. So this is very, very critical to make the app context very secure. So you can do identity and access management. You should. Not anybody should be able to just log into your app for any purpose. So you should have identity and access management. What you see in cloud computing is a manifestation. The IAM that you see in, like, let's say, in AWS or GCP is a manifestation of this basic identity and access management that is needed for, like, you need the API keys, you need database keys to be able to authenticate. Then, of course, there are algorithms and protocols that are needed or that can be used. I've just used WAS 2.0 to say that's one. It's an open source app, which is very, very common. You can use OpenID Connect. That's another security upgrade that, right? You use tokens for JSON web tokens. If you have a JSON type, then you can use web tokens, right? Similarly, you have the ability to have the DDoS attacks. Like you should not be exposed to have a DDoS, right? So you should have pre-signed URLs. You can have the best practices that I've listed there to say this will make your server more secure than just having like a standard IAM, right? Another one is having a purge pipeline. This is super, super critical to have a sustainable and secure app. You should not, or you should have a purge pipeline when a user deletes their data, like their account, a cascade signal must be sent and you wipe it out. It's called an automated wipeout. You A lot of these apps these days, whatever is for Google Docs or Google Workspace, has this wipeout. Similarly, there are other applications so that I am not using this for malintent, and there's also a commercial dimension to this. Like I have stopped paying, but I still want to use. So that is the commercial aspect, but then there's safety and security aspect of my automated wipeout. So these three or four are your security best practices that will make your app or the design really, really robust, right? So what should we sign the URL? It's like the tiny URL that you will get, like, or you can have in the session, you can ask that so that there's no DDoS on the session URL. You can pre-authenticate that and generate the tiny URL to be passed for further fetching. So you just pass on just the tiny URL, don't leave it. So you pre-authenticate and then share. Okay. What else? Oh, I think we have a robust design now. For the purpose of our use case, this is the final diagram that we end up with for our app to say I have all the best practices from security, from accessibility, from load balancing, from content development network, right? Content delivery network. This is for those one or two use cases that will be used by 800 million people is reasonably secure, right? So this is why it is so important that you go through a journey. Now, Will you get here on day one before you start coding? Absolutely not. Then there's no way you can reach this stage without having a bug, without having a code crash. There's no way you can do that. You have to iterate on your design to reach here at some point in time. Just for a fun fact, Gmail had 40 beta releases. What the Gmail that you see today has had 40 beta releases. So you will have to iterate to make it massively parallel, secure, safe, and performant. Right? Okay. Hope it did not make you sad. System analytical design is not something to make you sad. You'll have to learn more. You go through all of these references. Like I said, these terms might be, quite a few of them will be tangential and stage of treatment. But that's fine. It's totally fine. Just understand the concept of why we need this. Right? And I've shared some resources Mr. Sumit, so you can access this. It's not, there's no trade secret here. So you can go ahead and just read it and enjoy the learning. All right. I know I took way longer than I promised, but I'll stop and we'll see if you guys have any other questions. So, what is the purpose of the matrix program? Like gravitating. If you need the instant messaging in the case of like when you're communicating between two video operators using a subscription model, if you are trying to communicate through that, or if you're doing commenting on the videos, you would want to use a GMS queue or similar sort of queue. If you want to enable message, if you say no, I will just view, like I will just upload or view, no other messaging needed to start. To be able to communicate. One is that. The other is from a troubleshooting standpoint. So you could have a separate instance of the Chinese script to be able to troubleshoot your asynchronous requests. So you can always feed the log or the crash log into your JMS and you say, why did this asynchronous fail? It was supposed to run overnight. You would normally, it's the best practice just to have an asynchronous JMS key. But if you have a messaging service and you want to use it, I think you should use it. Yeah, any questions? Okay, this is not about how do you get a job at Google, but this definitely should empower you to design massively parallel. All right? Thank you, everybody. Thanks.
Thank you, sir, for such an enlightening and intellectually stimulating session. To formally express our gratitude, I would like to invite Mr. O.G. Ghosh, sir, HOD CSE Department, to deliver the vote of thanks.